Welcome, good people. My name is Joel Collier, and today we're going to talk about how to run a confirmatory factor analysis using AMOS, a structural equation modeling software program. So before we get into the nuts and bolts of the AMOS program, I want to talk a little bit about what is a confirmatory factor analysis, what are the parts that make it up, just so that we can have a better understanding of what it is and why we do it before we kind of jump into AMOS. So if I have kind of a simple little model here, which is customer delight leads to positive word of mouth. So this came from a restaurant setting, and basically what we were trying to understand is if they had a delightful experience, do they want to tell other people about it? So very simple model here. Um, but you can see that these two circles right here are unobservables. They're concepts that I can't really observe people doing. Like I can, you know, look at people, but I can't tell if they're delighted, and I can't tell if they're going to have intentions to spread positive word of mouth. You can see, well, I can look at somebody and he can be stone-faced, but he's still delighted. They're just not expressive. So these are kind of unobservable variables, and the way that we actually capture those unobservables is through observable means, and usually this is through asking survey questions, or a litany of other different ways, but it's a way to, we capture this through what we call observables, so things that we can observe. And the most popular one is usually some kind of manipulation, or you'll see it more times than not, survey questions. So in a confirmatory factor analysis, we're really concerned about the measurement properties. So we're trying to understand, do our observables that we captured, do they really capture or kind of help us to explain or understand the unobservable construct. And you can see this from an EFA and a CFA, they're very different. So from exploratory factor analysis, basically it just lets all constructs load on every indicator. You can see the circles are unobservables and those squares are observables. In this instance, we asked survey questions, 3 survey questions of each construct. But it lets you load on every possible indicator. And it tries to initially kind of take this first pass of saying, do all the items that measure, let's say, customer delight, do they want to kind of group up and kind of behave the same way? Are they different than other items? Do they distinguish from one another? And usually that's kind of our first pass. Now, when we get to the confirmatory factor analysis, you can see it's a little bit different in that we're not letting the unobservables, try to have a relationship with every indicator. We're only saying I'm only going to have a relationship with the indicators that I set out initially to start with to say these are capturing this construct. So customer delight has those 3 items that we initially asked them, and we're only going to let our unobservable load on those items. And so we're going to try to assess it that way. And this unobservable, those paths, those arrows going down to the indicators really represent the kind of the influence from the unobservable to its indicators, and it's kind of treated like statistical estimates. And they'll call these kind of estimates, and they're much like regression too, but they'll call these estimates factor loadings. So how well does this particular indicator load, if you will, on the unobservable or represent the unobservable construct? In the how AMOS actually represents these unobservables in a confirmatory factor analysis is you will typically see kind of the unobservable, and then you'll have paths to all the indicators, and then you'll also have error terms. So with each indicator, you're talking about they're probably not a perfect or perfectly accurate way to capture that concept. And so you're going to have what's called error, or just unexplained variance that takes place across, let's say, I surveyed 200 people. Well, let's say delight 1, or that first question of delight, it's got some unexplained variance in there. Some people said 7, some people said 5, some people said 6. And so maybe I've got some invariance in there, and so that unexplained variance is really just error. So we're going to model the error that's in each one of those indicators too. You'll also notice here that what SEM does is require this kind of assessment of kind of unmeasured covariance. So any independent construct is going to require a covariance between it. And in confirmatory factor analysis, pretty much all the constructs are considered independent constructs, all of them. And so all of them will have a covariance between each other. And so in this instance, we've got two constructs and one covariance, but if I had three, then that means I would have a covariance between each one of the constructs to one another. Yeah, 10 plus doesn't matter, it's the same thing. Obviously you're going to have a lot of covariances in that standpoint. And Amos will even prompt you if you don't have those covariances added. They'll be like, hey, don't you need a covariance? These are all independent. So it'll kind of prompt you too. You'll also notice in here that from Delight 1 and even from Word of Mouth 1, you'll see that the relationship from the unobservable to the observable has a 1, in there. And what this is it called, the term is called setting the metric. So Amos really needs for you to kind of give it a better understanding of like what is the range. And so it's in essence kind of setting the range out for Amos to kind of understand like, all right, so what is the range we're talking about here? And so that's necessary. If you don't set the range on each one of your unobservable constructs to its indicators, basically you'll have an error message. It'll come out as under-identified in Amos and it'll just bomb out. And that's probably one of the more prominent error messages that you get. That some people sometimes will delete an indicator and that was the one that was setting the metric and it just kind of blows everything up. Or they forget to actually set the metric when they're putting it into Amos. So in each one of these constructs, you can see we've got the paths that are going down there, and these paths are coming from the unobservable to the indicators or the observable constructs. You'll hear the term used interchangeably of indicators and observable constructs, and they're reflective in their nature. And you'll probably hear the term formative indicators. I've got another video that goes completely into trying to understand what is the difference between reflective and formative indicators, and so you can check that out if you're interested, but we're just going to keep everything simple right now, and everything is going to be what's called reflective, which means it's coming from the observable to the observable constructs. All right, so this is how we kind of lay it out. So let's get into Amos now. And we'll kind of show how this is done and what are the outputs, what do they mean, and all of those kind of good things. So first things first, I could go up here to the top where it says draw unobservable variables, and I could start drawing variables in here, and I could individually, draw each one of these out to an observable, but that takes a lot of time, and Amos just has a better way to do this than doing these individually. So if you see this icon at the top that says draw a latent variable, it really is pretty handy into doing this for you. So what I'm going to do initially is just kind of draw it out, and then I'm going to click in the middle of it, and every time I click it's going to add an indicator. And you can see too that it's already added it's already set the metric with one of those, and here's my indicators, and here are my error terms. So I had two unobservables, so I'm going to draw two of these and click that 3 times in the middle, and you can see it gave me 3 indicators. If I forget, if I actually had 4 instead of 3, I could go back in here and click another one, and it would add another. And so it's just a handy little way to kind of get to the confirmatory factor analysis without having to individually draw the circles and all the arrows and all the squares and all the circles or the arrows up here. It just kind of does everything for you. All right, so first thing we need to label our unobservables. So in here we're just going to double click into that, and it's going to bring up the object properties, and we're going to type in customer underscore delight. So you can't put spaces in this, so for using spaces I just use an underscore. And in this one we're going to call it positive word of mouth. Positive underscore WOM, word of mouth. All right, and we'll just do a little cleanup here just to make it a little bit easier for us to see. All right, so now one of the things too to get your observables Amos has a nice little drag and drop function. So if you go ahead and tell Amos where's your data file, it will basically pull up all of the observables that are in that data file. And for instance, with customer delight, we've got 3 items here: delight 1, delight 2, and delight 3. And so I can just drag this over and just drop it right in. All right, so it just kind of takes it and says, all right, I'm making you an observable now. And then if I had for positive word of mouth, I can do the exact same thing. So I take positive word of mouth 1, I'll just drop it in. Positive word of mouth 2, drop that in, and 3, and there we go. So we got now our unobservables for both of those. Now we have our observables. We've set our metric. We have not labeled our error terms, which we need to do that. But before we do that, let's kind of just clean up some things a little bit here so that we can see, kind of all of our indicators just a little bit better, because right now it's kind of jammed. Okay, so I could individually double click into each one of these and label. It'll bring up the object properties, E1, E2, E3. Usually you want to use an E and a number. Amos really likes E reserved for error terms. Or you can go up to the handy function up here at the top called plugins, and then if you go down to where it says name unobserved variables right here, it will label all your error terms for you, E1 through 6 right here. So at this point, it labeled it for us. We didn't have to individually go in each one of those, which was nice. All right, so the last thing that we need to do is we need to put a covariance between our two unobservables. Remember, Amos treats these all as independents, and if they are independents, they require a covariance between those. So just to recap, we got our unobservables, we have our factor loadings or our paths, here. We've set the metric on each one of those. We now have indicators or observables, 3 for each, and then we have our error terms listed. So we're ready to go. So we can come over here to calculate estimates and let that run. Down here, before you kind of get down to the data, you can see if it ran or not. It says chi-square right here, gives us chi-square number, and it also gives us degrees of freedom. So we know that it ran. Look, we'll go to the view text right here and just kind of go into the specifics. So with the view text, initially you're going to get notes for model. This is going to give you, again, chi-square, how many degrees of freedom that you had. And let's go down to the estimates now. So in the estimates, this is going to give us the loadings that we have. And so what I asked for too is for it to give me the unstandardized but also the standardized estimates. And if you're curious on exactly where to go to get those, if we go into Analyze Properties and we go into Output, you can see right here it says Standardized Estimates. I also clicked Squared Multiple Correlations because it's nice to include that too. But if you're looking like where I got that in the output, it comes from up here into Analysis Properties. All right, so let's jump back to the output in the estimates link. And so initially at the top, this is going to give us the unstandardized estimates here. So this is the unstandardized estimate. The CR stands for critical ratio, but that is our t-values for each one of these. And this last column is our p-values. The p-values that are listed as 3 stars means that it's less than 0.001. So initially, just looking at this, we can see that all our standardized, our unstandardized regression estimates for our positive word of mouth and delight are highly significant. So our t-values are in like the 20s. And so the unstandardized estimates really don't tell us a whole lot in confirmatory factor analysis. When you're starting to see other kind of analysis in Amos, you'll see a lot of unstandardized estimates that are presented. But really, when it comes to confirmatory factor analysis, really standardized regression weights are more beneficial. And what I mean by standardized regression rates, it means I'm literally taking all of the values and I'm putting it on kind of a 0 to 1 scale. So it's standardizing those estimates so that you can compare across constructs. Because let's say I had a confirmatory factor analysis, and we asked one of the questions on a 7-point scale and the other one was on a 5-point scale. Or what if it wasn't even on a scale at all? What if it was a value such as spending money in different situations, and so they're dollar figures. And so what it does is it takes these kind of raw numbers and puts it in kind of a standardized form so that you can compare across those. So from the standardized regression weights, we can see for our first three values here of delight 1, 2, and 3, the lowest one's 0.835, 0.847, 0.93. So what's a good standardized regression weight? Well, usually anything that is 0.7 and above is usually considered acceptable. Well, where did this 0.7 kind of come from then? Well, if you take these standardized estimates and you square it, what it gives you is what's called the squared multiple correlation, which means how much of the variance are you explaining with that item in regards to the unobservable construct. So with this first one, delight 1, we take customer delight, which is 0.847, and we square that. We come down here to delight 1. Then we're explaining about 72% of the variance in there. Really good. So where does 0.7? Well, 0.7, if you square that value, gets 0.5. So you're explaining at least half the variance in there. So anything below that you're talking about is not really necessarily a very good item. So you're in the point, I mean, if it's right at like 0.69, I mean, it's borderline. You can still keep it. But if it's like a 0.5 or a 0.4, that's a bad item. It's not helping explain the unobservable construct. So in this instance, with our standardized regression weight, everything is above 0.7. So now we've got, some understanding of, okay, it's above 0.7, so they're all, not only are they significantly loading on their constructs, but they're loading strongly. And, not just from a significant standpoint, but from a actual explanation of a variance, you can understand too that they're doing a good job of trying to explain that unobservable variable. So initially we can say, okay, not only are my constructs all kind of loading together on the unobservable construct, but they're explaining, the variance in that. So first things first, each item looks like is appropriate, and it's trying to help explain that construct, which is good. The next thing I want to look at real quickly is model fit. So model fit is this idea is how well does the model, or what we kind of set up in Amos, that two construct kind of model, how well does it match up with the observed covariance matrix? And what it does is it tries to assess, is the model as a whole, if you will, kind of representative of the covariance matrix. And just to kind of give you an idea of what's acceptable, these values in the model fit at the top, you can see in parsin is the number of parameters that you're estimating, and C-min is chi-square value. So our chi-square was 0.13 with 8 degrees of freedom. Chi-square is usually very sample size specific too, and sensitive. And so sometimes you'll see people really do what's called the relative chi-square, which is they take the chi-square value and they divide it by the degrees of freedom, and they get kind of a value here. And if it falls between that kind of 1 to anywhere between, I've seen it, 1 to 5, is somewhat kind of saying that it's an appropriately model fit. Some other ones that you'll see that's used a lot is the CFI, the TLI, NFI. These values, if they're kind of conventional wisdom says if they're over 0.9, that it has an acceptable fit. More of a good fit would probably be closer to 0.95 and above, but an acceptable fit would be 0.9. And then down here you'll see a popular one of root mean square error of approximation. And this one is if it's below actually 0.05, it's considered to have kind of a good fit. So in each one of these instances too, you can see we've got kind of a good model fit too. So there's way more to this than just this quick video that I'm explaining, but I wanted to kind of give you an introduction into how to run a confirmatory factor analysis. And one of the things that you have to think about too is what's called validity. So even though we tested these in the confirmatory factor analysis, usually you'll have to do kind of separate tests to confirm what we call convergent validity, which did all these items converge on this unobservable construct, and is there discriminant validity, which means do these items discriminate from one another statistically. And that's going to be kind of in a future video if you're interested in that, on to how to determine kind of convergent and discriminant validity. And that's just kind of an overview of confirmatory factor analysis. If you're looking for more information on how to determine validity, more kind of step-by-step instructions of confirmatory factor analysis and also model fit, and there's some other ways that you can sometimes assess if you have problems in your model fit through modification indices. I would encourage you to check out my book, Applied Structural Equation Modeling Using AMOS. I go into a lot of details specifically on this and more kind of easy step-by-step process of what is confirmatory factor analysis, what are the potential error messages that you get, and also how do I present my results with confirmatory factor analysis when we get to the write-up stage. Like, give me a template for that. So an example of that's given as well. But that's all I got for this week. So if you got any questions about this, feel free to post those out there, and I'll try to get back to you as best I can. And if you saw value in this, I would ask that you like and subscribe for more videos to come.